So this is the SBP paper 3 ya. Okay, yang as I said just now, memang tiada salinan sama kamu lah. This is SBP paper 3. Okay, I just want to go through with you a paper that, let's say kau first time kau nampakkan, what are the things that you should look for lah. Okay, so you have diagram 3.1 shows the image of a lady taken by a camera. So you kind of know that kalau ada kamera terlibatkan, this is probably a lens experiment. Probably. Okay, and diagram 3.2 shows the image of a lady when she moves closer, okay, to the camera. So di sini ada perbezaan jarak over here and over here. So when you look at this situation, okay, you kind of know that this is probably the object distance. Okay, if you have already memorized the 9 experiments that I asked you to memorize, this is probably a familiar one lah. Cuma, those of you that I did the test, there's a trick to this, right? You have to really watch and see dia punya RV yang penting, kan? So in this case, the RV, look at the images. So we're obviously talking about the size of the images lah. Sorry, let me zoom in a little bit more. Okay, so obviously we're talking about the size of the images. Okay, so this one will be probably MV object distance. Okay, and then the RV will be the image height. Okay, so for those of you who don't know what I'm talking about, so there was one time saya buat ujian dengan, I can't remember which class, it's either S1 or S2 lah. Okay, then saya bagi diorang satu soalan yang macam ni bah. Okay, yang ada lens punya soalan lah. Okay, because I gave all the classes, I gave all of you 9 experiments and I said, okay, I want to test 2. So this was one of the questions. Not this question lah, tapi something similar to this kan. Terus ramai orang, dia punya eksperimen yang dia hantar is object distance and then the RV is image distance. Which tiada kaitan dengan the situasi di dalam soalan inilah. Okay, so my reminder to you is, even though you already memorized the experiment, please be careful, especially when the experiment kan dia sangat similar. Okay, the object distance and image distance, object distance and image height kan, dia punya setup semua sangat sama. Okay, it is the exact same setup untuk kedua-dua. Cuma benda yang kamu ukur sahaja yang berlainan. Okay, so ini yang akan membezakan. This will differentiate between the people who are going to get the 12 full marks, okay, and the people that are only going to get 8 or 6 out of 12 lah. Okay, so I want to remind all of you that paper 3 is the paper that you should aim to score. Kalau saya 40 over 40 lah. You should be able to score 40 over 40, but you must be careful. Okay, antara there are a few things that people will always tell students. There are a few things that I will always tell students about paper 3. So by the time you hit paper 3, you're kind of half dead already lah, because sebelah pagi kamu ada paper 1 and then lepas itu kamu ada paper 2. Okay, so anyways, balik kepada cerita saya. So paper 1 is like already. Then lepas itu kamu ada 2.5 jam, 2.5 hours of paper 2. By then it's already 12:30 in the afternoon lah. And then kamu akan menduduki paper 3 kan at 2 o'clock and dia habis at 3:30. Okay, so usually students who sit for paper 3 kan, they kind of want to finish early lah. So macam dia sangat penat sudah. Okay, but I am reminding you that paper 3 is the paper. Okay, yang you should aim to score a perfect score. Okay, of course kita sangat mengharapkan okay bahawa all the experiment yang kita cover akan kena lah. Okay, but you know, things like drawing graph, making sure that the reading is correct, all these should be, you please pay special attention lah. 1.5 hours is a very long time actually. Okay, sangat lama masanya. Okay, and it's always good to practice doing paper 3 again and again and again, so that you are used to the 1.5 hours. Okay, I need to stop my baby. I need to start discussing the question. Sorry. Okay, so this is an experiment that we've seen already. Okay, convex lens, light bulb, and screen. Okay, so I won't really go much into this, except that just to remind you of how the experiment looks like. What is this? SBP. Okay. SBP, hold on, let me see, where is the answer? Okay, sorry. Okay, the SBP. Let me see. Okay, so this is the setup lah. Okay, object distance affects the height or the size of the image. Okay, and then everything else is the same. Don't forget kalau lens, okay, kalau lens dia punya constant variable is always the focal length. Okay, focal length of the lens lah. Itu or power of the lens. Okay, so try to remember if it is a lens experiment, ingat saja the constant variable is focal length of the lens or power of the lens. Okay, jangan fikir benda-benda yang lain lah. Okay, then everything is here. Cuma they didn't really show the arrangement of the apparatus lah. Okay, tapi saya rasa kalau kau sudah ikut all the sessions with me during the holidays, you know what this experiment is about lah. Okay. All right, the second one, the second question, astaga, hold on. Mana ni? Okay, the second question is this, and this is a very interesting question. When I saw it, I was like, apa bahasa soalan ni kan? Pelik betul. Okay, so this is a metal wire that is stretched between two fixed clamps. Okay, so this is, high. Okay, so you have a clamp over here. Okay, so the clamp is over here, and that is in a tense state. Oh, sorry, the clamp is over here. Okay, anyway. So a magnet is placed near the wire. So this is the magnet. Okay, as shown in diagram 4.1. So the metal wire is displaced vertically. It's basically just a guitar lah kan, and then dia petik itu guitar. And then release between the two different poles of the magnet. So you have this wire over here yang kena tarik and then lepas tu kena lepas. Okay, so the electric current produced is shown on a sensitive galvanometer. So when you see this, obviously the first thing is you take a look at the galvanometer lah. Okay, just to remind you, galvanometer, the further you are away from the center, the bigger the current. So this one and this one, kalau dia punya pesungan adalah sama, it is the same amount of current. Jangan tertipu daya oleh galvanometer. Sebab galvanometer dia punya kosong di tengah. Okay, kalau voltmeter, okay, if a normal voltmeter, the zero is on the side here, macam biasalah kan, 0 and then 1 and then after that 2. So the bigger it goes over here, the bigger the voltage. But galvanometer, no. Galvanometer, the nearer you are to the center, the smaller the current. Okay, so dia bermula kosong di tengah. Okay, so obviously we find that over here the current is high and here the current is low. Okay, sebab the anak panah over here is nearer to 0 than compared to here. And because galvanometer dia mengukur current, so you kind of know that this one is the RV lah. So ini yang kita baca. Okay, yang kita baca adalah RV. So the RV is the current. So what about the manipulated variable, the MV? Okay, so in this case, we find that what is changed is the displacement of the metal wire. Okay, the displacement of the metal wire will, so kalau dia sikit saja dia kena displace macam ni, dia punya current jadi macam ni. Tapi kalau dia diangkat lebih tinggi macam yang ini, the current will become bigger. This is not an experiment yang kita sudah bincang. That's why I want to discuss this lah. Okay, so ini yang saya panggil saki-baki experiment lah. It's like 1-2 negeri saja yang tanya soalan ni. So itu sebabnya saya tidak berapa fokus sangat. But since we're discussing other paper 3 questions, I thought okay lah, saya discuss. So this is the electromagnetic induction. Okay, this is the electromagnetic induction experiment. And the electromagnetic induction antara salah satu daripada big clue lah, one of the biggest clues that you kind of, okay, this is experiment electromagnetic induction is galvanometer. Because dalam syllabus SPM, tidak banyak eksperimen yang menggunakan galvanometer. Okay, I think only the electromagnetic induction experiment uses a galvanometer. The rest all will use voltmeter, ammeter, blah, blah, blah. Okay, bar magnet, well, yeah, bar magnet got a lot of experiments lah. Tapi memang galvanometer ini, kamu nampak je galvanometer kan, you know, okay, this is probably electromagnetic induction experiment. Okay, so I'm going to show you the answer and you guys can screenshot this if you want, or you can download this scheme also lah. Saya rasa saya ada kasih masuk bahkan the schema. I'm getting lost. Where is the, okay, so this is the marking schema. So this is how it looks like. Okay, so the current depends on the speed Astaga. The speed, the height, or the compression. Okay. But actually, I want this one lah. Kalau kamu mau senang, bagus kamu cakap height saja. Sebab the experiment kan, dia punya setup adalah begini bang. Either the solenoid berada di atas and the magnet berada di bawah, atau you drop the magnet into the solenoid. The usual one, yang kebiasaannya adalah there is a meter rule over here. Okay, so this is a meter rule. Okay, then you put the solenoid over here, and then the bar magnet over here, and then this is the value of H. Okay, so that's the normal one. Ini adalah magnet bar lah. So this one is a little bit unique sebab yang solenoid dia kasih jatuh. Also can, no problem. Okay, so one thing that is missing in this drawing, is the presence of the meter rule lah. Saya suka kalau kamu masukkan meter rule sekali, in case you forget to write it over here. So in paper 3 when experiment kan, let's say you write down the list of apparatus kan, tapi kamu terlupa satu benda. Okay, tetapi yang kamu lupa itu, kamu ada lukis di dalam arrangement of apparatus. Okay, most of the time you will be given the full mark anyway. Okay, because because ada elemen belas kasihan lah, sikit belas kasihan. Okay. So if the speed, how do I do the definition of operation? Okay, so hold on. So this is current induced depends on the speed lah. Okay, so there was a question just now. If you use the word speed, okay, so the speed of the kejatuhan magnet or the speed of the kejatuhan solenoid, okay, how would you, sorry, what was the question? How to define? Do you need to define? How to do the operational definition for speed? This is actually, how to measure the speed or how to determine the speed. Okay, same thing to the person that asked me the question privately. The height, kalau kamu mau cakap speed, if you're going to talk about speed, then you have to write the operational definition. Okay, the operational definition. Then you say that the speed is represented by the height. H, begini. The experimental setup is still the same. Okay, cuma banyak bergantung kepada macam mana kamu tulis kamu punya inference lah. If you write your inference using the word speed, then you have no choice. You have to write down the operational definition for speed. But if you already know this experiment, the original experiment kan dia memang menggunakan perkataan height. Okay, the textbook, the blue book, and the whatever book you use, okay, all the experiments, dia punya jawapan memang height. The experiment itself, kalau dilakukan di sekolah kan, memang height. Okay, so if you use height kan, then you don't have to worry about operational definition. Sebab height, kamu boleh ukur, kamu boleh tetapkan, okay, 15 cm, 20, 30, 40 cm, begitu. Okay, so good question lah just now. If you use speed, then you use height as the operational definition for the speed. Okay, so the greater the height, the greater the current induced. Okay, I want to also mention that the word induce must be in. Okay, sebab ini adalah electromagnetic induction. Jadi current yang terhasil bukan current semata-mata, tetapi dia adalah current, dia adalah induced current. Okay, so you need to mention the word induce when you're talking about this. Okay, ada juga yang tanya, bolehkah? What if I write the answer? The greater the height, the greater the induced current. No problem. Okay, induced current induced, tiada masalah. As long as the word induce is in, that's the more important thing. Okay, to state the aim of the experiment, this is our standard 5 words to investigate the relationship between, and then you go on and say the height or the compression and the current induced. Okay, once again, let me remind you, the word induce must be in. Okay, so that you get the full mark. Okay, saya pernah dengar, okay, I've heard before, if you don't write the word induce, macam diorang akan tolak sedikit markah lah. They won't salahkan semua, but they akan penalize lah. Okay, so ini adalah konsep yang sangat penting, induced current. Okay, so state the manipulated, yada yada. Okay, one fixed variable. It is probably the same as the experiment that we do for, what is that experiment? The left hand rule experiment. Okay, yang ada itu rod bergerak bahkan. The fixed variable, the constant variable is the same. Okay, we use the words strength of the bar magnet. Okay, so certain experiments kan, ada beberapa eksperimen kan yang even if you don't know what's the experiment kan, if you memorize the fixed variable kan, should be okay one. Okay, because most of the time the fixed variable tidak banyak berubah. So tulis OD dapat markah kah? Okay, that's a good question. So since I already discussed this, okay. Yang saya ajar lah, okay, I always teach my students to separate the operational definition. Walaupun actually in the question tiada like, okay, nyatakan the operational definition. Dia tiada cakap begitulah. Okay, but I always tell my students, okay, you need to write the operational definition sebab saya khawatir kamu lupa sebut di sini. Okay, so saya macam mengsengajakan, I purposely force you to write down the operational definition so that you don't forget it when you're writing the procedure. So procedure kan ramai orang akan tulis automatic macam tu, then they forget. Okay, because we need operational definition when we cannot directly measure something. Okay, for example, speed. You cannot directly measure speed, so kamu kena wakilkan. You have to represent it by the height. Tapi kamu tidak akan dapat markah kalau kamu tulis begini. Tetapi kalau kamu tidak nyatakan, if you don't mention that the speed is represented by the height somewhere in your procedure over here, okay, kamu akan hilang markah. Sebab, let's say kamu punya hypothesis, the greater the height, the greater the speed, the greater the current induced. Contoh. Let's say your hypothesis is this. Then your investigation, to investigate the relationship between the speed and the current induced. Then the manipulated variable also speed. Kamu tulis. Contoh lah. Then suddenly in the experiment kan, kamu cakap measure the height. Okay, so dia akan menjadi sangat pelik tau, like, hello, dari awal kan kau cakap speed kan, terus the last thing you cakap, okay, measure the height. Then kau tidak sebut, you don't tell us, why must we measure the height? I thought we were supposed to measure the speed. That's why the operational definition must be there. So that people, when they read, they know that dalam kepala kamu kan, the height diwakili oleh the speed. Okay, so actually, kalau kamu tulis di dalam prosedur, tiada masalah. Okay, tetapi saya punya pengalaman, saya selalu nampak calon dan saya selalu nampak pelajar dia lupa tulis. So that's why I force, saya paksa kamu semua, you need to write the operational definition as a separate line so that you don't forget. Especially kalau benda itu tidak boleh diukur. The good news is tidak banyak benda yang ada operational definition. Okay, not everything got operational definition. Okay, tetapi benda yang kamu tidak boleh ukur, like speed lah. Speed you can measure, but you don't have the alat to measure. Kau mau ukur pakai apa? Another one is inertia. Inertia definitely has to be operationally defined. Okay, and this is probably Shane's favorite experiment lah, yang pakai G-clamp itu. Okay, the time taken to travel, blah blah blah. Yeah, okay, so that's inertia. Another one which we discussed is the liquid pressure kayak itu, yang kita pakai balloon, the Tissot funnel experiment. Right?
Yes.
Liquid pressure. So yes. The liquid pressure experiment, the liquid pressure is operationally defined. Must be operationally defined. Okay, so certain things like that lah. Okay, so state the method of this one, then the method of measuring yada yada, and then after that, of course, you have the same thing. Please don't forget that you need to write 5 values. The values you write over here must be the same as the values that you write over here and also over here. Okay, you must write 5 values. Okay, kalau ada 0.0, tiada 0.0 itu tiada masalah, but you cannot just say repeat the step using other values. Tiada markah. You must nyatakan. Okay, even if, okay, let's say contohnya kamu sangat gelabah lah and you forget, and then kau tuliskan 30.0 cm kan, then the next one kau tulis 31.0, 32.0 kan, macam terlalu kecil lah kan, also no problem. Okay, I think my students yang saya ajarkan, I already told you, you are the architect. Okay, it's not your problem if the engineer cannot do it. Kamu design saja the experiment. Kalau boleh dibuat, kalau macam apa ini, okay, tidak boleh dibuat kan, it's not your problem. Your problem is just to design the experiment. Okay, and then of course, this one is the same thing, except that who can tell me what is wrong with this?
Unit
Kalau
dia.
saya nampak, ya, kalau saya nampak begini kan, terus saya bagi salah. Okay, why? Because there's no unit over here. Okay, jadi pakai microampere lah. Okay, sorry, microampere. Okay, guys, please unit jangan lupa. Okay, apparently there's this picture going around, and some people are saying, oh, this reminds me of 70 what? Apples, bananas, oranges. Yeah, so please unit sangat penting. Okay, unit sangat penting. Next one is I want to discuss MRSM because MRSM, the paper is also quite interesting. Okay, MRSM not to say interesting lah, tetapi dia guna Beyblade. Okay. Yeah. Sorry, I don't know any Form 5s that still play Beyblade lah. But I guess if there are 40-year-olds that still play Pokemon, I guess there are 17-year-olds that play Beyblade lah. So the unit must be microampere, not necessarily. It can be ampere also. Okay. As I said lah, microampere is dia memang perfect experiment lah. Dia memang microampere lah. Tapi kalau kau pakai ampere tidak salah. Okay, as long as you use the right unit lah. Okay, don't use micrometer. Alamak. Okay, tiada lah. Okay, so the Beyblade attached with one piece of heavy metal. So this is the heavy metal. Astaga. You know why I wanted to choose this experiment? Because Shane owes me an angpao. This experiment is Shane's experiment. So this is one piece of heavy metal. This is two pieces of heavy metal. Okay, two pieces of heavy metal over here. So didapati bahawa 3.2 took a longer time to stop spinning. Okay, so whenever you see the word time, we are thinking about the word period lah. Okay, and time usually is period lah. Okay, dia punya selang masa. And since this is one metal and two metal it looks like a mass versus period question lah. Looks like lah. Okay, is it mass versus period? Yeah, I think it's mass versus period. Or it can also be mass versus inertia. And actually this is the experiment lah. This is the mass versus inertia experiment. Okay, tetapi mass versus inertia experiment ada dua. Okay, ada dua. Tetapi yang lebih famous adalah yang menggunakan the hacksaw blade. And since I thought all of you here in Form 4, all of you would have done this experiment. Sampai, do you remember yang kita buat, then ada yang sampai dia punya bila gergaji tu patah because you use the heavy plasticine. Do you remember that? Okay. People in 4S1 last year will remember this like the G-clamp lah, because that is Shane's trademark. Okay. Yeah. People want to oscillate the plasticine, he want to oscillate the G-clamp. Okay, so yeah. Okay, so that's oh dear. I think seumur hidup saya tidak akan lupa lah eksperimen itu. Okay, you will always be Shane dalam kenangan. Okay, okay. So the MRSM punya scheme. Okay, you know what should I? Okay, let me share it with you in a while but let me talk about the question 4 first lah. Okay, so this is obviously this question obviously the manipulated variable is mass. Okay, and then the RV is inertia. And if you remember what I said just now, the RV has to be operationally defined. Okay, so the operational definition will be inertia is represented by what? By time taken lah kan? Time taken for, biasanya how many oscillations kita pakai? You can decide. Okay, standard answer is 20 oscillations lah. Okay, 20 kali ayunan. So 1, 2, 3, 4, 5. But you can use 10 also. Okay, 10 and 20 is realistic. 5 is a little bit too little lah. Terlalu sikit. Okay, 100 oscillations is a little bit extra. Okay, setiada masa lah mau tunggukan 100 oscillations. Okay, so usually we use 10, 20 or 30 lah. Okay, I will show you the experiment in a little while. Actually, I thought kan that the marking scheme for MRSM tiada, but then after that Tristan told me, oh ada pula. Okay, so I will probably share this a little bit later lah. Okay, so this one is an electric drill bit, okay, spinning at minimum current. So the speed over here, this is minimum current lah. Okay, this question is the exact same question as the fan question. Kamu tekan fan nombor 1, dia punya kipas bergerak slow. Kalau kamu tekan fan nombor 3, okay, dia punya fan, kamu punya kipas berputar dengan lebih laju. And this one, those of you who are under me, you will know this experiment already lah. This speed ini mewakili the current. Okay, and because dia melibatkan putaran, okay, the fan, okay, it represents the what is it? Force like that. Force kan? Yeah, force. Okay, so this is current versus force, and this is another electromagnetism experiment. Okay, so this seems to be the trend for the Form 5 experiment. Macam sepertinya lah kan, the electromagnetism experiment is very popularly asked this year lah. Okay, so teruskan berdoa supaya eksperimen ini juga yang keluar, walaupun dia punya lukisan sangat susah lah. Okay, and obviously you know that this is the experiment because of what they provide, this one. Ini ya, memang satu clue yang sangat besar. The C-shaped iron yoke is this one. Okay, then you put the magnet over here, you put the magnet over here. This thing yang berbentuk huruf C ini, okay, the one that I'm coloring blue color, okay, this is the C-shaped iron yoke. Okay, then you put the magnets. This is the magnet north and south lah. Doesn't matter lah whether it's north and south, but it's the magnet. So this is a very big clue. Bila kamu nampak ini the apparatus, then you're like, oh, okay, C-shaped iron yoke kan. There's only one experiment in your entire Form 4, Form 5 that uses a C-shaped iron yoke, and the word is so unique that if you forget it's probably because you haven't seen the experiment before. So if you want to see how the experiment looks like, please check out my TikTok account and then you can see the experiment lah. Okay, so yeah, anyway, C-shaped iron yoke is a very important clue. Okay, because that will tell you that, okay, this is the force against current experiment. Okay, so how is the experiment looking like? I have to stop this sharing screen and change to this current screen. Okay, so this is how this is Shane's experiment. Okay, the one with this is the jigsaw blade. Sorry, I don't know if you can see the mouse that I'm showing around. Okay, so this is the jigsaw blade. Dalam bahasa Melayu dia dipanggil bilah gergaji kah itu. Ya, dia bukan jigsaw sebab yang macam puzzle itu. There's a reason why it's called jigsaw blade lah. I also don't know why. Okay, then di sini kamu letak plasticine lah. I can't remember which class was it that last year kan patahkan saya punya jigsaw blade. I think it's S2 and S3 lah kalau saya tidak silap. And I remember last year when I did this experiment, terus saya kena complain sebab asal si Marcus buat eksperimen kan mesti itu bilah gergaji patah. So yeah, anyway. And then Shane, this is the G clamp, okay? The G clamp is used to clamp the jigsaw blade. Okay, bukan digunakan untuk oscillation. So yang kamu ubah adalah the mass. Okay, the one that you change is the mass, and then the responding variable is the period of oscillation alias inertia. Okay, you can also write inertia if you want, but you have to make sure that you write the operational definition. Okay, inertia is represented by the time taken for berapa oscillation ini? Oh, di sini 10 complete oscillations. Okay, 10 ayunan lengkap. Okay, measure using the stopwatch and recorded lah. Okay, kalau this step kamu tiadakan, also actually no problem, you know. Kalau kamu dia punya period kan, kau tidak kira pun tidak apa. Sebab kau time taken also is good enough actually lah. Okay, but if you can remember the entire experiment, if you write period, dia memang sangat cantik. It's a definitely A+ answer. Okay, so speaking of the difference between A and A+, these kind of things are the differences between A and A+. Okay, both A and A+ kan, you usually get about the same marks, but sometimes we look at the quality of the answer to determine who is supposed to get the A+. Okay, so So if you don't write the period of oscillation is calculated by using the formula T equals to T over 10, then usually if we see this kind, then we will say, okay, this is probably an A student lah, not really an A plus student, because the A plus students will remember all these kind of things lah. Okay, so because they don't remember anything else, they remember nonsense steps like this that is unnecessary, but will give them the A plus. Okay, anyway, same thing. Please make sure that you have 5 values, okay, over here. And then, of course, the time taken. Okay, then this is a very nice and complete graph. Okay, remember, don't draw the line. Just make sure you draw the axis and state the symbol and the unit. Okay, symbol and the unit is very important. Okay, the second experiment, the one with the drill. So it's the force depends on the current. Okay, the higher the current, the higher the force. To study or to investigate the relationship between current and the force. And then the current, okay, this one, the force has to be operationally defined. So is the distance kah kita? Yang saya ajar kamu apa? Distance kah itu? Distance of the movement of the copper rod kan? Is that what I taught you?
Betul lah, betul lah.
Okay, so this one dia cakap sesaran lah, the displacement. Also no problem lah, same thing. Okay, strength of magnet. Okay, notice what this guy is writing. A very common answer we always see is number of magnet. Number of magnet tak boleh. Okay, remember that this one, type of magnet, number of magnet. The perkataan type of memang tidak boleh. Okay, so type of liquid lah, type of water, no type. Okay, so if in an experiment that involves electromagnetism, please use the words strength of the magnet, kekuatan magnet. Okay, sebab itu ada nilai. Okay, so as you can see here, this is the arrangement. This is the C-shaped iron core. Okay, then there's a switch over here. You have the magnets, and then if you can see over here is the copper wire lah. Okay, yeah. So anyway, so blah blah blah. Make sure you have 5 values of currents. Okay, so 5 values of currents. Then you measure by using a meter rule. Okay, always don't forget this. Responding variable. You need to tell me how you measure. No? Don't just say measure the displacement of the sliding wire. Stop. Tiada markah. You must tell me apa alat yang kamu pakai. Okay, to measure the responding variable. Very important. Okay, so the same thing over here, the graph and this one. So I will share this scheme with your respective groups after this class. Okay, so you don't have to, like screenshot. Nanti saya akan share juga ini. Okay, the third one, which is the one that I want to share, I wanted very badly to share this because this is the most bizarre question paper. It's very bizarre. Okay, bizarre as in pelik lah. It is the Selangor paper. Okay, so this is the situation. Diagram 3 shows 2 potholes, P and Q on the road. It's such a bizarre question. Pothole Q is smaller than pothole P, but much deeper. So they both contain the same amount of water after the rain. So jumlah airnya adalah sama. Now, it is observed that when the sun comes up, P dries up more quickly than Q. Why do you think so? Yeah. What is causing, apa yang menyebabkan P to dry up more quickly than Q?
Surface area.
Big hole. Big hole. Okay lah, fine. Big hole, surface area lah kan. But what is causing it to dry up?
Evaporation.
Yeah, it's an evaporation question, Okay, so what is the MV and the RV, you think, in this situation? The MV, obviously, macam kamu cakap tadi, is the surface area lah. Okay, this one has a bigger surface area. This one has a smaller surface area. What is the RV?
Time taken for the water to evaporation. Yes.
Okay, time taken for water, for evaporation lah. Okay, time taken for evaporation alias juga dikenali sebagai the rate of evaporation. This is our apparatus, table lamp measuring cylinder. Okay, measuring cylinder is a cylinder penyukat yang panjang begini ni. Okay, this is a measuring cylinder yang ada senggatan di tepi ni. Okay, so okay, so obviously the table lamp acts as the sun lah. Okay, dia adalah matahari buatan. So, so you put how? I, okay. So I will show you the answer in a little while. I just want to show you that this is one of those bizarre experiments by Selangor. But they didn't stop there, no. The second question also is equally as bizarre, but not so bad lah. Okay, so two babies, mass of 6 kg and 12 kg, oscillating in a similar baby cradle. Same spring system. Okay, so dia punya spring adalah sama, except that the baby in 4.1, okay, oscillates faster because the 4.1 is 6 kg and the 4.2 is 12 kg. So this is actually the same answer as the MRSM lah. This is mass versus inertia. Yeah, inertia. Okay, and the big clue for us will be the spring. Okay, so this is the other inertia experiment yang tidak melibatkan the jigsaw blade, the hacksaw blade. Okay, atau G-clamp. Okay, this is the spring inertia experiment. Okay, so if there's anything that you want to take back today, especially if you're thinking of exploring other experiments, you may want to prepare the two inertia experiments, one using the hacksaw blade and one using the spring. Okay, it's the same experiment, no, except that dia punya alat adalah lainan. Okay, macam mana kalau you know that this is an inertia experiment dan soalan dia bagi spring, tetapi kamu guna juga jawapan hacksaw blade. Zero, tak boleh. Okay, because dia memang sudah bagi tahu with the use of the apparatus such as the spring, the load and other apparatus. You must use, be very careful even if you know the experiment, make sure that kamu punya alat adalah sama dengan apa yang soalan minta. Okay, kalau dia cakap spring and load, you have to use spring. You cannot use hacksaw blade. Kalau dia minta hacksaw blade, then you use the hacksaw blade. Okay, walaupun dia punya eksperimen adalah sama. Okay, so this is the marking scheme. So this is the evaporation experiment. Dun, 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 over here. So you need to change the surface area. Okay, so the surface area is represented by the diameter of this petri dish. Astaga. Okay, the diameter of this petri dish. So the operational definition of the surface area, okay, is represented by the diameter of petri dish. So kamu letak satu petri dish with water, and then lepas itu you put the fake sun lah, the table lamp over the top. Then you measure the time taken using a stopwatch. Okay, then actually I don't know lah kan. If you honestly ask me do you think this happens in seconds? Let me see dia punya ni. Oh, dia punya ni line pula. Ooh, okay, let's see. Hold on. I may be mistaken. Okay, so dia cakap surface area affects the rate of evaporation. So dia cakap final volume of water. Oh, okay. That means yang kamu tetapkan adalah the time. The larger the surface area, the higher the rate of evaporation. So set up the apparatus as shown. Pour 30 centimeters, 30 centimeter cube of water into a petri dish of diameter 3 cm. Place it directly under the lamp. Okay. Record the final, so means the masa itu yang kamu tetapkan. So you just want to know how much water is left. I think that makes more sense lah kan. Daripada kamu letak semua lah air dan lepas tu kau tunggu sampai dia habis evaporate lah. That one takes a longer time and it's not practical because how you know when dia betul-betul habis evaporate kan? Like you're not going to look there at the water slowly. Oh my goodness, watching water evaporate is a very long process. So yeah, this makes more sense lah. You record how much water is left after 5 minutes. Okay, so this will be the D lah. D will be the diameter of the petri dish. V will be the final volume of water after 5 minutes. Okay, so and once again, this is not acceptable. It has to be V centimeter cube against D and then slash cm. Make sure to have the unit lah. Okay, ini tidak boleh. Okay, so once again guys, this is a Form 1 experiment lah. Okay, actually. So which is why I'm very shocked to see it in this physics trial paper. Okay, but I was talking to somebody just now. He said maybe we just prepare for the worst lah. Hope for the best, but we prepare for the worst. This is probably the worst kind of possible soalan yang kamu mungkin boleh dapat. Soalan yang kamu langsung like tidak dapat jangka lah. Okay, the spring experiment is like this. Okay, so we do the same thing lah. So we record the time for 10 oscillations, and then after that you calculate the period of oscillation. Okay, if you don't have the period of oscillation punya ayat, then it's just, you know, you may not be able to get the A plus lah, but you should be able to get the A. Okay, but yalah, dia punya setup sangat senang lah, makan spring and load itu saja. Then of course you have the stopwatch lah. Okay, kamu ambil stopwatch untuk mengira masa. Okay, so just be careful lah with the inertia experiment. Di sini dia cakap mass and period lah. You can also say inertia lah. Okay, because I would say that this is an inertia experiment. Okay, pun tiada masalah. Okay, so that is the three negeri punya experiment. So for me as your physics teacher, I have covered all the experiments from all the states lah. Okay, and I hope that it has been helpful. If you are asking me for any more advice about the paper 3 experiment, I would say if you have already memorized the 9 experiments, atau kalau kamu ada sudah dalam tangan itu 9 experiment, and you're thinking of tambah experiment just in case, I would suggest the inertia experiment. Okay, the 2 inertia experiments. I really think that you shouldn't waste your time with the rate of evaporation experiment because this is not in your syllabus. Okay, it is in a Form 1 syllabus. Kamu harus tahu tapi kamu tidak perlu tahu untuk peperiksaan. Okay, peperiksaan memang cover Form 4, Form 5 saja. Jadi dia akan cover lebih daripada itu atau kurang daripada itu. So if you ask me, I would say maybe you should prepare the inertia experiment. Okay, just as a, you know, in case, I mean, if you have a lot of time and you want to memorize more experiments, go ahead lah, memorize the inertia experiment. Okay, it's a good experiment to memorize. Okay, all right. The other thing I want to do is to, as much as possible, I want to discuss the paper 2 MRSM paper. So diagram 1 shows a thermometer with electromagnetic wave, okay, used to measure the body temperature of a man during COVID-19 outbreak. So the name, the type of electromagnetic waves, this will obviously be infrared lah. Okay. Okay, electromagnetic wave can propagate in a vacuum, okay, definitely can. The only thing that cannot propagate in vacuum, okay, the only wave yang tidak boleh bergerak dalam vacuum is sound waves. Okay, so for those of you who spent the last few days watching Space Sweepers on Netflix, okay, please be informed, any space TV show, there is no sound in space. So yang kamu dengar boom boom itu kan di angkasa lepas kan? Doesn't exist. There is no sound in outer space. Okay, so last time I used to be like, wow, bayangkan kalau kita Star Wars kan, itu kan tiada bunyi, it's just tu je. No sound at all because sound cannot travel in outer space. You need air, kamu perlukan udara. Okay, you need something to carry the sound from one place to another, and that's the job of the air molecules in our atmosphere. Imagine if we don't have an atmosphere, all you will be hearing in this session will be, okay, that's all you'll be hearing because we need air molecules, okay, to travel through, for sound waves to travel. Okay, so remember this, electromagnetic waves can travel. Okay, name one characteristic of electromagnetic waves. There are many characteristics of electromagnetic waves. If you don't remember, okay, the easiest one is travel at speed of light. Okay, it can also be a transverse wave. Okay, or if you want to remember in terms of the phenomena, okay, it can be reflected. Then, tapi kamu kena sebut keempat-empat. You cannot just say one. Okay, so if you want to talk about the characteristic in terms of the four-wave phenomena, you must mention all four. You cannot just say it can be reflected. Tak boleh. Okay, it can be reflected, refracted, diffracted, and interference. Okay, sorry, there's no past tense for interference lah. Interference, tak boleh. Okay, just say interference lah, doesn't matter. Tiada juga ed di belakangnya lah. Okay, so it can be reflected, refracted, diffracted, and interference. If you are going to use this answer, make sure you write all four. But the easiest answer is always this. Okay, travels at the speed of light. It's a very important characteristic of electromagnetic wave. Okay, so give one detrimental effect of excessive exposure to electromagnetic waves in A1. Okay, so the wave is infrared lah. So what is the not so good thing about infrared? Is not that your brains will be affected. Please, okay? The only effect it has is skin burn. Okay, this is the only possible effect. Infrared is seperti cahaya matahari atau ring light, okay, yang lama-lama di atas muka kamu bah. Obviously you get sunburn lah kan. Okay, infrared works around the same principle. So if you too long exposed to infrared, you will get skin burn. But trust me, it is easier for the sun to burn your skin than for the thermometer thing to burn your skin. Sorry, I'm very triggered by this question. Sorry. Okay, because yeah, so skin burn. Okay, and the reason why I want to mention this skin burn, because there are a lot of people, okay, and I've seen quite a number of videos, their students answer what, oh, the brains will be affected lah, they will get mentally retarded lah, yada yada lah. People really believe all this nonsense about the thermometer. Okay, anyway, stop being triggered. Okay, question number 2. Diagram 2 shows a hydraulic system. A force F is applied to heavy objects. So obviously the principle over here will be Pascal's principle. Okay, Pascal's principle. As a reminder, please don't salah eja nama orang. Okay, Pascal is P-A-S-C-A-L. P-A-S-K-A-L is the name of a movie. Okay, yang melibatkan tentera askar Melayu. Okay, askar Malaysia, sorry, not Melayu. Okay, but Pascal is a real scientist lah. Okay, so a force F is applied to lift a heavy object. Compare the pressure at point A and point B, so the pressure will be the same. Okay, only the force and the surface area is different. So Pascal's principle is pressure is equally applied. Okay, so pressure di sini adalah sama. Okay, that's Pascal's principle. Okay, so hydraulic jack, yada yada, astaga, what is this? Okay, so a man pulled down the handle with a force of 50 newtons. So you have the force over here, 50 newtons. Cross-sectional area of the small and the large piston. Where is the small piston? Okay, small piston is over here, large piston is over here. So this is 0.05 and this is 1. Okay, calculate the pressure. Formula for Pascal's principle will be F1 over A1 equals to F2 over A2. Biasanya, Pascal's principle formula is not given because the pressure formula is always given. Pressure is F over A. Okay, so usually this is not given. Okay, sebab you are supposed to know that Pascal's principle pressure sama. So F1 over A1 di sini adalah sama dengan F2 over A2 di sini. Okay, it's the same pressure lah. So what you will get is 50 over 0.05 equals to F2 over small piston. Sorry. So the pressure is F over A. Sorry. Pressure is F over A. Okay, so you get 50 divided by 0.05 and the answer over here will be 1000 Pascal. Okay. Yeah, Pascal lah, the standard formula for pressure. Oh, dia tidak bagi tahu pula kan? Oh, they didn't ask you to calculate the load. So interesting. Okay, state how to lower the load. How do we lower this load down? Okay, so that is the function of the release valve lah. Okay, so this is an interesting question because usually biasanya people will ask, okay, calculate the F2 lah. Ini adalah soalan yang biasa. But they try to up the game and they say, okay, we don't want you to just do calculation. We want you to look at this and tell me, how am I going, if let's say I push this handle, how am I going to lower this load? Okay, so obviously what needs to happen is this one needs to be open lah. The two release valves needs to be open so that this one, the oil over here can travel downwards. Okay, dia boleh masuk macam ni. So the answer for this would be to open the release valve. Okay, buka, injak, pelepas. Okay, you open the release valve so that you can this one. Another way, okay, another way is, and this is very logical lah kan. Kalau kamu mau benda ini turun, di manakah kamu harus tarik ini pemegang? Are you going to pull it to the left or push it? Sorry, pull it to the left or push it to the right? Which one? Okay, it will obviously be pull the handle lah. Okay, pull the handle. Tapi kau kena sebut lah to the left. Okay, sebut the diagram. Pull it this way. Because when you pull it this way, this one akan bergerak ke belakang. And so, you know, yang lain semua akan ikut lah. Air, the oil will flow, you know, more onto the left side. It's not very logical, okay? My logic saja ini sebenarnya. This is a good answer. This is also an acceptable answer. Let me check. Yeah, okay. Pull the handle to the left. Okay. All right. Number 3. Bottle of cold milk is soaked in warm water before feeding it to the baby. Okay. On diagram 3.2, draw the direction of heat flow between the warm water and the cold milk. Okay. So this is the concept of thermal equilibrium. Okay, so equilibrium. Oh my goodness. Okay, so remember in thermal equilibrium, those of you that I teach, you know that there are certain keywords lah. Okay, thermal contact lah, heat flow lah, no net heat flow, yada yada, and the temperature is the same. Tetapi, as long as the warm water and the cold milk are touching, they are in thermal contact, there is always heat transfer between the two. Most students will always answer this one. Okay, the heat will flow from the milk into the water. Okay, which is wrong. Okay, it's like relationship. It has to be two ways. Okay, even though one is giving more and the other one is giving less, doesn't matter. Two ways is always better than one-way relationship. Okay, so I stand with the people who are in one-way relationship. Okay, so the answer has to be not just a big arrow outside, it also has to be a small tiny arrow, okay, from the cold milk into, from the cold, oh wait, sorry. Warm water and cold milk. Hold on. The warm water is outside. Sorry, my mistake. My mistake. It's supposed to be the warm water give more to the cold milk, right?
I didn't get that. Could you try again?
No, you don't have to try again. It's okay. Okay, so it should be the bigger arrow inside like this. Okay, sebab ini yang panaskan. And then the cold milk will transfer some heat, okay, outside. So it's very important that you draw the difference between both the arrows just to show that, okay, there is more heat from the water than this one. Okay, in the marking scheme here it says betul-betul reject one arrow only. Kalau kau lukis one arrow kan memang salah. Okay, all right. Next question. Name the physics principle involved. So this will be thermal equilibrium. Okay, this is also one of those words that a lot of students tend to spell wrongly. Okay, so just be careful with that lah. Okay, diagram 3.3 shows an uncalibrated thermometer used to measure the temperature of the soup. Okay, calculate the temperature of the soup. Okay, so the temperature of the soup is here lah. This is the current temperature, but this formula also is not a very popular formula. So the temperature theta equals to L theta minus L0 over L100 minus L0 times 100. Okay, so is this one minus this one, okay, and then over this one minus this one, okay, times 100. Okay, so what you will get is L theta is 25.5 minus 5 over 33.0 minus 5 times 100. Okay, so the answer will be about 73.21 degrees Celsius. Okay, it's a very common question, commonly asked in paper 1. Ini adalah soalan paper 1 yang sangat formula, menggunakan formula ini. Tetapi ini pun satu-satunya formula yang jarang diberi. Okay, I don't, adalah sometimes akan diberi, tetapi dia jarang diberi. So it may be a good idea for you to take note of this formula. Okay, L theta minus L0. Both memang L minus L0. Okay, L0 is the 0 degree Celsius punya panjang lah. Okay, L100 is the 100 degrees Celsius, and etc. Oh, are we done with this question so fast? Oh, Nina, what happened to the temperature? I was waiting for this question. What happened to the temperature after 10 minutes? It will become the same temperature lah, sebab sudah mencapai thermal equilibrium. There was no problem. Okay, diagram, this one shows this one. Okay, so please don't forget, this is known as the power rating. Okay, power rating 240 volts, 1800 watts. Please go and find out now how to write the power rating punya definition and what does the 240 and 1800 mean, unless they ask in this question. Oh, tiada. Okay. So a student uses this iron for 10 minutes and the current flow is 7.5 amps. The first question is, what is the meaning of electric current? This is a standard definition. Electric current is the rate of charge flow. Okay, rate of charge flow is the definition of electric current. Calculate the amount of charges that flow in the iron. Okay, the amount of charges is the current divided by the time, but the time must be in. Sorry. Kenapa saya tulis divide? Sorry. Is current times time multiplied by time, except that the time must be in seconds. Okay, so the current flow is 7.5. Time is 10 minutes, but you need to change it to seconds. Okay, so you will get about 4,500. Amount of charge, the unit is coulomb. Okay, C for coulomb. Okay, I'm losing my voice. Diagram 4.2 shows a negatively charged balloon. X is tied by a weight on a table. Okay, you can see bar. So diagram 4.2 shows the balloon X is brought closer to the dome of a Van de Graaff generator. Okay, so Van de Graaff generator is one of those things that we have in the lab, but it is already spoiled. Itu saja. Oh, the soalan belum. So what will happen to balloon X? Okay, if this is negatively charged, means that everything around here is negative. Okay, so this will all be negative. When the dome is switched on, when the Van de Graaff generator has been switched on, this one you kind of need to remember lah. Okay, when you switch on the Van de Graaff, what happens is all the positive charges will gather here. Okay, this is the Mr. Bean punya the Van de Graaff thing kan, dia pegang terus dia punya rambut tidak naik kan, tapi dia pegang orang yang nguang itu kan. Yeah, so it's not true lah, but basically the Van de Graaff generator, when you turn it on, all the positive charges will go up onto the kubah and all the negative charges will be spinning all around here. Okay, dia akan berubah macam itulah. Okay, so what happens to balloon X? Think about it lah. If this is all positive charges and the balloon is all negative charges, macam mana kamu tahu negative charges? Sebab dia sudah memberitahu. Okay, the balloon is negatively charged. So this is very natural lah. Okay, you see a positive, you see a negative, what will happen is X will be attracted, okay, to the Van de Graaff generator. Okay, so the field pattern will be as I drew just now. Tapi the field pattern is different. Field pattern is kalau ini adalah positif, ini adalah negatif, kan? The field pattern will be at least 3 lines over here. Okay, going from positive to negative, and then some more curved ones lah. Okay, kalau kamu mau extra betul ni, go ahead lah and draw. As long as dia punya arrow adalah dari positif kepada negatif. Just like magnet, north to south bahkan. Okay, so the field pattern will be always this way. Okay, magnetic field always flows from north to south, electric field patterns always flow from positive to negative. Yes, Nicole.
Sir, if the question kan dua markah, so memang the ayat just like that kah? The
Ayat?
answer, I mean.
Oh, okay. Oh yeah lah, I'm supposed to explain. Sorry. X will be attracted to the Van de Graaff generator because the dome will be positively charged. Yeah, positively charged. Yeah, so that's the explanation lah. Okay, so 1 mark for what happens to X. Ini satu markah. Okay, and then this one will be the second mark. Yeah, I forgot. Thank you for mentioning it. So the dome will be positively charged. This one is a kind of macam fakta lah. Okay, when you turn the Van de Graaff generator on, the dome will become positive, and then the tali down, the rubber down here will become negative. Okay, will become negative. So don't worry about that lah. Okay, is this the end of question 4? All right, let's do until question 6, and then I will call it a night lah. Then we'll cover the rest of the MRSM paper after your sejarah paper next week. Wow, next week's the SPM gun. I'm so excited for you guys. Like, you know, okay, it's almost over lah. I'm not excited because like, oh, 1 more month of suffering, but you know, like, okay, come on guys, it's almost over. And then you can finally dye your hair and punch how many holes in your ear or in your nose or in your tongue if you're into that kind of thing, you know, or I don't know. The only thing that you cannot do is makan berjemaah lah kan. Itu saja yang kita boleh buat. Tengok terus bermessage lah kan kalau saya cakap pasal SPM saja. Go ball lah. Sure, go ahead. Let's support Sir Marcus in his attempt to grow more hair by growing bald. Thank you, everyone. I'm very thankful for your support. Laugh sarcastically. Okay, diagram 5.1 shows a boy rocking an elastic spring rocker. Okay. Oh, the boy looks so happy. Diagram 5.2 shows the same boy rocking on another spring rocker. Okay, so both use identical springs. The difference will be, this is a short one. This is not just long, but it's used 2 springs. Okay, what is the meaning of elasticity? It's a very long definition. Okay, ability of an object to, saya lupa sudah. What is it? Ability of object. No, not ability. Okay lah, tendency lah bahkan sebenarnya. Okay, to return to its original state. Okay, after a force has been removed. Something like that, I think. Ability of an object to return to its original shape after the force is removed. Okay, so Jeremy's answer is almost the same as mine. Okay, state, shape pun boleh lah. Okay, let me check the marking scheme. Marking scheme cakap property or tendency of a matter. Oh yeah lah, actually you're right. Maybe property is a better word. Property of an object to return to its original size and shape when the forces that are acting on it are removed. Yeah, maybe property is a better word. Okay, observe diagram 5.1, 5.2. Compare the number of springs. This is the easiest question in the world. It's very obvious because it's right in front of you. The only way you cannot see this is if you forgot to bring your specs. 5.2 is more than 5.1. Okay, that's the standard answer lah. The compression of the springs. Take a look at this. Same boy, tetapi ini lebih mampat. Okay, so that means the 5.1 is bigger than 5.2. Okay, the compression of 5.1 is bigger than 5.2. Please don't forget to use full sentences when you answer the compare questions. Okay, avoid using lazy answers like this. Okay, these are not A+ answers. Come on. Stiffness of the springs. Okay, so the stiffness of the springs will obviously be 5.2 is more stiff than 5.1 lah. Okay, because, hold on, let me just check something. Yeah. Okay, yeah. So the stiffness of the spring, 5.2 because there's 2 springs in there, so dia lebih stiff lah, and dia kurang compress. Okay, so the stiffness akan menjadi lebih tinggi and 5.2. So relate the number of spring and the compression. So the bigger the number of spring, look at the compression. Compression means berapa banyak dia kena mampat. Okay, so this is obviously only very little lah. So the bigger the number of spring, the smaller the compression of spring. Lebih banyak spring, then dia suka untuk compress lah. Relate the stiffness and the compression of spring. So the bigger the stiffness, yeah, the bigger the stiffness, the smaller the compression of spring. Okay, which is this one lah. Ini lebih stiff, because there's two springs, there's more support. Okay, there's more support, so it is stiffer. Harder, stiffer basically is like harder for you to compress or kasih panjang. Okay, sebab dia macam kamu tarik dua orang. Which spring rocker can support children with greater mass? Okay, then obviously you have to explain your answer lah. So obviously the answer is 5.2 lah kan, sebab dia ada two springs. But you shouldn't mention that there is two springs. You should mention why. So what if it is two springs? Okay, so you can say that the stiffness is greater. That is one possible answer. Okay, another one is the springs are arranged in parallel. Okay, and obvious answer that saya rasa kalau kamu banyak menjawab soalan elasticity, you will know this lah. Okay, the spring constant, okay, is bigger. So either one of these, okay, is an acceptable answer lah. Okay, but these two are explanations for the spring constant. Okay, so the spring constant becomes bigger when it is more stiff. Okay, dia lebih keras. Kekerasan bukan kekenyalan tau, dia stiff. Okay, and then secondly, they are arranged in parallel. More springs in parallel is always tougher, okay, than just one spring. Or more springs in series. Okay, kalau series springs kan begini, lepas tu begini kan, ini sangat lembek. Okay, like kau boleh, ini sesuai untuk apalah, bungee jumping lah, Tarzan lah, where you want it to be not so stiff lah. Okay, last question then we call it a night lah. 6.1, 6.2, show the magnetic field pattern produced by electromagnet. Okay, this is an iron nail. Okay, and then obviously this. What's the difference between this and this? Oh, tengok ba ini. Difference is the thickness of the wire. Okay, the thickness of the wire is the big difference between this. So what is the meaning of an electromagnet? After 1.5 years of almost learning everything, this is like, okay, so an electromagnet is a temporary magnet. Okay, the greatest word that you can use for electromagnet is a temporary magnet. Okay, when, that is produced when current flows through a wire or coil. Okay, so the key word is the word temporary magnet. And then macam mana temporary magnet itu terhasil is apabila arus mengalir melalui wire atau coil. Okay, when the current flows through the wire or coil. The actual definition for electromagnet is very long lah. Okay, but this is good enough. Okay, kalau saya baca, wait, let me see the scheme. The scheme says, electromagnet is a magnet made up of winding or a coil of insulated wire around a soft iron core so that a magnetic field is produced when a current passes through the coil. 1 mark. No need lah, guys. Okay, no need lah. Don't suffer just for 1 mark. You just remember the word temporary magnet and how the temporary magnet happens. Okay, let's compare the number of turns in a coil, the distance between the magnetic field lines, thickness. Okay, so the number of turns, if we see over here, 1, 2, 3, 4, 5, 6. Okay, 6 number of turns over here. 1, 2, 3, 4, 5, 6. I feel like I'm in Sesame Street. Okay, so the number of the turns of the coil is the same. Okay, number of turns of coil is the same. The second one is the magnetic field lines. So look at this distance over here. Okay, and compare it to this distance over here, you will find that the magnetic distance of 6.1 is bigger. The field lines are much wider. Okay, so 6.1 is bigger than 6.2. Sebab 6.2 macam rapat-rapat dia punya garis. Tengok ni. Okay, compare with this. Satu saja, sedih. Okay, so 6.2 is lebih rapat. So the distance is smaller for 6.2. The thickness of the conductor, this one, I think you can see by now lah. 6.1 is less thick. Is smaller than 6.2. Okay, dia punya thickness. So 6.1 is smaller than 6.2. The strength of the magnetic field will follow the distance between the magnetic field lines. So 6.1 is greater than 6.2. Okay, so relate the thickness of the conductor, the distance of the magnetic field lines, and the strength of the magnetic field. But because it's 2 marks, so saya perlu dua relationship. Okay, so which one would you relate? Yeah, actually this is quite easy lah. So the bigger the thickness, the smaller probably, the magnetic, the distance, okay, of magnetic field lines. Kan? Yang lebih tebal yang dia punya distance nearer. Okay, correct. So another one would be the strength of the magnetic field. The bigger the thickness, yeah. The bigger the thickness, the bigger the thickness, the bigger the strength, bahkan, yeah, the bigger the strength of magnetic field. Am I doing this correctly? Is it correct? Yeah, strength of magnetic field. Yeah. Okay. Hold on now. Distance of magnetic field line 6.1 is bigger. But 6.2 is thicker, bahkan. 6.2 is thicker. If it's thicker, then the distance will be smaller, correct? So this first one is correct. Sorry, the bigger the thickness, the bigger the strength of the magnetic field. Which magnetic field is actually stronger, 6.1 or 6.2? Oh, sorry lah, sorry. 6.2 is bigger than 6.1. Sorry, 6.2 is bigger than 6.1. Kan sebab lebih banyak garis di sini. Yeah, 6.2 is bigger. Okay, yeah, so this is the balik. The bigger the thickness, correct lah, the bigger the thickness, the bigger the strength for the magnetic field. Okay, there is a third possible option if you guys want. Okay, the smaller the distance, sorry, the bigger the distance lah. The bigger the distance of magnetic field, okay, the smaller the strength of magnetic field. So any one of these three answers will be acceptable as long as you write 2 lah. Okay, so as a reminder, just remember that when you read the question, also look at the marks. The marks will tell you how many sentences you need to form. Okay, don't just write one word and then mengharapkan 2 markah. It doesn't happen that way lah. Kalau saya relate thickness of the conductor, oh yalah, itu yang saya cakap tadi lah. Okay, dia ada 3. Okay, based on diagram 6.1, state one other method to increase the strength of the magnetic field. Oh, okay. This one senang lah. How can I increase the strength of this magnetic field? You either increase the current, okay, or use our good friend lah. Or use apa itu? Soft iron core, kan? Our good friend. Or another one, it will be increase the number of turns. Ini pun boleh. Okay, so many answers. Either one also is fine, but this will probably be the most logical lah. Kau tambahkan current, terus dia punya magnetic field akan bertambah lebih kuat. Okay. All right. I think let's call this a night. So I will see you when I see you. Yeah, maybe we'll just do one more session to finish discussing this paper. The MRSM paper is actually a good paper lah. A lot of overachieving questions, especially in the section B, section C. But we'll just discuss it as one go.